February 1st, 2021, Sturgeon Bay, Wisconsin. The Great Lakes are frozen solid. The shipping season is over. The bulk carrier Blough sits dormant in winter layup. Deep in the lower engine room, a small diesel-fired furnace fights the sub-zero temperatures. It is the only thing keeping the ship's pipes and machinery from freezing. At 01:31 in the morning, a small piece of cast aluminum gives up. 65 pounds of machinery crashes down, a rigid fuel line snaps, and in the darkness of an unmanned engine room, diesel begins to spray onto an open flame. The Blough is a classic Laker. Built in 1972 in Lorain, Ohio, she is a colossal beast. 858 feet long, designed to haul iron ore across the industrial heartland of America. She is a self-unloader. Beneath her massive cargo holds lies a complex system of rubber conveyor belts. These belts run the length of the ship, passing through the engine room and angling up to the stern to offload cargo. This efficiency is her greatest asset. But the rubber belts running through the engine room are also a dormant fuse, waiting to be lit. But in the winter of 2021, the belts are still. The crew has gone home while the ship sits in the cold. While the ship was being prepared for winter, a secondary heating system was installed, a powermatic furnace. This would help keep the pipes from bursting and machinery from seizing. This wasn't a piece of heavy marine engineering, but instead a common unit typically used to heat buildings, and it had a troubled history. 1 month before the fire, the furnace stopped working. The igniter was failing. The chief engineer and the second engineer tried to fix it. They were not trained on this specific unit, but in their line of work, they repaired a wide range of equipment. Believing the issue was the igniter gap, they removed and then reinstalled the heavy 65-pound burner assembly multiple times. The manufacturer recommends a pedestal support, a leg to hold the weight of the burner. But on the Blough, there was no pedestal. The burner hung entirely by a single aluminum coupling secured by 2 small set screws. Every time they took it off and put it back on, they stressed that aluminum coupling. Eventually, a technician was called in to fix the electrodes, but the structural damage to the mount was already done and went unnoticed. There was one more critical flaw. The fuel line feeding the burner was rigid stainless steel. If the burner moved, the pipe would not flex, but instead snap. February 1st, 01:31. The aluminum coupling fractures and gravity takes over. The burner falls to the floor of its enclosure and the rigid fuel line shears off. Diesel fuel being fed from the tank above sprays directly onto the burner. Investigators would later find a soot line inside the box that told the story. The fire started inside the metal box after the burner fell. The heat rises. Directly above the furnace is a steel deck, and resting on that deck is the port side conveyor belt. Rubber ignites at roughly 380 degrees Fahrenheit. The conveyor belt catches. The fire now has a highway. It travels up the trunk, spreading from the engine room into the aft house of the ship. At 01:31, the temporary wireless smoke detectors pick up the danger, and the system sends out text alerts as designed. It notifies the shipyard gate guard and another cell phone sitting in an empty office, but it does not notify the one person that matters most. There is a shipkeeper on board, a lone watchman sleeping in his quarters who is not on the text list. 7 minutes pass. 7 minutes of unchecked fire growth with fuel pouring on it. Finally, at 01:38, the smoke fills the shipkeeper's cabin, tripping his local alarm. He wakes up to a wall of black smoke. He manages to escape down the gangway, uninjured, but the vessel is already lost to the flames. The fire burned for over 12 hours. When NTSB and Coast Guard investigators finally entered the hole, the damage exceeded $100 million. They found the burner on the floor. They found the broken pipe, but they also noticed what wasn't there: a fusible link safety shutoff valve. It is a standard safety device costing less than $50 and is designed to melt and snap shut in the presence of heat, cutting off the fuel. The National Fire Protection Association requires these valves for shoreside installations, but because this furnace was on a ship, regulations for this specific type of winter furnace were a gray area. The valve was not there. Had that cheap valve been installed, the fuel supply would have been cut the moment the fire started, and the fire likely would have burned itself out inside the box. The ship survived, but the damage was catastrophic. The investigation concluded that the probable cause was the repeated removal and reinstallation of the burner, which led to the coupling failure. The NTSB issued new recommendations. They called on the Coast Guard and the American Bureau of Shipping to develop strict standards for these oil-fired winter furnaces, treating them the same respect as the ship's main propulsion. The Blough fire serves as a freezing reminder. There is no such thing as harmless machinery on a ship, and in the dead of winter, complacency is the most dangerous cargo of all. Fortunately, no one was injured or killed. This channel is dedicated to analyzing marine casualties through the eyes of a current mariner, and to ensure these lessons are learned and never forgotten.